Hello everyone, welcome to this video. I am Akshayan and this is the seventh video of our data science series. And in this video, we are going to discuss part D of our question paper 1, which is nothing but collaboration analytics, compatibility, and pairing. In this presentation, I will walk you through the dataset, the consistency matrices, the dissimilarity measures, and finally the ranking of the most and least compatible student pairs. So let's dive into the part D. So collaboration analytics is a method used to understand how well people can work together in teams. It helps us identify compatible pairs, reduce conflicts, and improve team performance. In this task, our goal is to analyze collaboration among students using skill-based and gender-based data. Through this, we can decide which pair of students would collaborate best in a project scenario. So let's look at our problem statement. So in this part, we are asked to do four things. First, construct consistency matrices for every pair of students. Second, compute invariant dissimilarity between these pairs. Third, identify the best and worst collaboration pairs. And finally, include gender to see how compatibility changes. I will take you through each part step by step. So let's proceed then. Let's do the data set overview first. So here's the data set. We have three students A, B, C. Each student has a gender, either male or female, and four skills. Here are the skills. A skill can be either P for present or N for not present. The important point is that skills are asymmetric, meaning a PP match is good but PN is a mismatch. Gender, on the other hand, is symmetric. We simply check whether genders match or not. Let's see the consistency rules. To compare any two students, we apply these simple rules. If both P, it's a match. If both have N, it's also a match. But if one has P and the other one has N, it is a mismatch. We will apply this for all pairs and for all skills. So now let's construct a consistency matrix for AB. Let's start with the first pair, A and B. We can compare skill by skill. In skill 1, A has P, B has N. In skill 2, A has N, B has B, P which is also a mismatch. In skill 3, A has P, B has P, which is a match. In skill 4, A has P, B has N, which is also a mismatch. So A and B have three mismatches out of four skills. So let's remember this thing and let's continue and construct a consistency matrix for AC. Now let's see for A and C. For skill first, A has P, C has N, which is a mismatch. Skill 2, A has N, C has N, which is a match. In skill 3, A has P, C has N, which is also a mismatch. And in skill 4, A has P, C has P, which is a match. So in AC consistency matrices, we have two mismatches out of four. Let's also remember this and continue and construct a consistency matrix for B and C. In B and C, there are three mismatches out of four. We can see here. Likewise, now let's see the dissimilarity calculation. Now we have to convert mismatches into a numerical measure. The formula is very straightforward. Dissimilarity equal to mismatches divided by total skills. For AB, the mismatches are 3 out of 4, so the dissimilarity is 0.75. For AC, 2 out of 4 gives 0.5. And for B and C, again 3 out of 4 gives 0.75. Now let's look for best and worst pairs. Best pair is AC, of course, because it has the lowest dissimilarity of 0.5, while the worst pair is ABBC. Both have uh, dissimilarity of 0.75 each. So based on these values, we can identify collaboration quality. The best collaboration pair is one with the lowest similarity, which is A and C with a score of 0.5. As I said, the worst collaboration pairs are AB, VC, with a similarity of 0.5. So at this point, skills suggest that AC is clearly the most compatible pair. Yeah. Now, let's see the gender-based adjustment. Now, the question asks us to reevaluate compatibility by including gender. A is male, B is female, which is a mismatch. A is male, C is a male, which is a match, and B is female and C is a male, which is also a mismatch. So AC gets no penalty, with AB and BC get EC. AB and BC each get an additional mismatch. So let's also see our revised compatibility rankings. If we add this gender mismatch as one extra mismatch, A, we get AB as 0.75 plus 1, 1.75, 1.75, and zero point 0.5. Even after including gender, AC remains the most compatible pair, and the rankings stay consistent. The male-male match between A and C slightly strengthens their compatibility score. So now let's interpret our results. So what we learn from this is that uh, skill alignment is the dominant factor in collaboration analytics. Gender plays a secondary role in the dataset, but it can still influence compatibility in some contexts. For example, if teams require diversity or if gender-based communication styles matter. However, here the skills carry more weight, and the final rankings is unchanged. So let's talk about the conclusion from the part D. To conclude, we analyze the collaboration dataset by constructing consistency matrices, computing dissimilarities, and ranking pairs. We found that AC is the best collaboration pair, both with and without gender considered, while AB, BC show higher mismatches and therefore lower compatibility. This analysis demonstrates how simple data-driven methods can help from effective student teams. So this brought us to the end of our video and to the end of our seventh video on this series. Thank you for listening. I hope this presentation helped clarify how collaboration analytics can be applied in practical scenarios. And thank you for your time. Let's meet in the next video.